Hi, this is Chuck Winkelmann here to prove number 1 on homework P5. The problem states, prove the following using the first principle of mathematical induction. For each natural number n, 1 cubed plus 2 cubed plus 3 cubed plus any numbers plus n cubed is equal to n times n plus 1 over 2 all squared. So our first step is going to be the base case, where we have n equals 1. So we'll say 1 cubed, and there's nothing added onto it, equals 1 times 1 plus 1 over 2 all squared. 1 cubed is equal to 1 times 2 over 2 all squared. 1 cubed is equal to 1 squared, and 1 is equal to 1. So the base case holds true, which means we can move on. So we're going to assume for any natural number k that 1 cubed plus 2 cubed plus 3 cubed plus any amount of numbers plus k cubed is equal to k times k plus 1 over 2, all squared. And we're trying to prove that 1 cubed plus 2 cubed plus 3 cubed plus any amount of numbers plus k plus 1 cubed is equal to k plus 1 times k plus 2 all over 2 squared. So we know that before k plus 1 comes k, and we already assume this equation is true. So any amount of numbers leading up to this is k amount of numbers, which means we can plug this in right here. So we're going to say 1 cubed plus, we're not going to say that. We're going to say k times k plus 1 over 2 squared plus k plus 1 cubed is equal to k plus 1 times k plus 2 over 2 squared. So now we are going to expand the square. So we're going to have k squared times k plus 1 squared over 4 plus k plus 1 cubed is equal to k plus 1 k plus 2 over 2 squared. And then we're going to factor out k plus 1 squared. So we're left with k squared over 4 plus k plus 1 is equal to k plus 1 times k plus 2 over 2 squared. And then from there, we are going to simplify this expression here. So we'll have k plus 1 squared times k squared plus 4k plus 4 over 4 is equal to k plus 1 times k plus 2 over 2. And then we can simplify this even more and say k plus 1 squared times k plus 2 squared over 4 is equal to k plus 1 times k plus 2 over 2. And then from there, we can take the squares out and say k plus 1 times k plus 2 over 2 is equal to k plus 1 times k plus 2 over 2 squared. Sorry, I apologize. They're all squared. And this holds to be true, and thus this relationship is proven. So from there we can look at a formal proof and say we need to prove that for all natural numbers n, 1 cubed plus 2 cubed, or I guess the sum of cubes, is equal to n times n plus 1 over 2, using the first principle of mathematical induction. And then you see our base case holds to be true, so we can move on with the proof. And then we have our inductive hypothesis, so we assume the formula holds for some arbitrary natural number k, as seen. And then our inductive step is just all this math that we just showed up here. And since this matches the original formula for n equals k plus 1, the proof by induction is complete. Thank you.